Hello, and welcome back to Quantitative Reasoning Online. We've concluded lesson 14 when we did the 14C conclusion and observational studies. So let's commence and let's look at lesson 15, statistical studies, part 3. And let's go into 15 and look at it. So 15A preview. The video game diet. What that's going to be like. Not very nutritious eating video games, but we'll find out. So 15A, Quantitative Reasoning Online. Lesson 15A. Nuts. Ooh, chocolate. Everything's better with chocolate. What's that, bacon? So let's see. In this one, we're going to look at distinguishing between quantitative and categorical variables, between explanatory and response variables, and identify treatment levels. Ooh, we're talking about experiments here. Treatment, that's an experiment. Okay. Quantitative, okay, that's an actual measurable. Categorical, that's basically just doing counts of, hey, how many blue-eyed people are there? How many football players were the 17 on their jersey? Categorical is also known as qualitative. I'll get in a second. Can I just erase that? Qualitative characteristics. Explanatory response. Explanatory is typically the x-axis. Response is the y-axis. Basically, the x variable explains the response in the y variable. Let's see what we got further on. So, in the next class, you will learn more about experimental studies. Remember that in experimental studies, researchers manipulate an explanatory variable to observe changes in a response variable. Tutorial for the preview, lesson 15, part A, the video game diet, begins here. I'll learn more about variables at HTTP, Oswego, whatever. What does that look like? Take a look. See this guy. Ooh, there we go. We have your quantitative. Quantitative, like I said, it's measurable. Meaningful arithmetic operations make sense. Heights, age, crop yield. Categorical, or also known as qualitative. There you go. Any variable that is not quantitative is categorical. Category variables take a value that is one of several possible categories. Unnaturally measured category variables have no numerical meaning. Example, hair color, gender, field of study, college attendance, political affiliation, status of disease, infection, and so forth. Okay. So yeah, this would be a very worthwhile page for you all to look at on your own. The response variable, the outcome of a study, explanatory variable, that which is being altered or being manipulated. Explanatory, also the independent or predictor variable. Response variable, the dependent. Worthwhile page to look at. Remember how we got it. not that page. Highlighted it, copied it, just went to another general web page. Ooh, you can't see that, can you? Get a search bar, paste, click, and there you is. Good enough. And of course, M to your personal statistical dictionary as needed. So, read the passage about quantitative and categorical variables. Which of the following is not a quantitative? Remember, quantitative is I can work arithmetic with the numbers. I.e., average, median, etc. So I take a bunch of people's height. Okay. If I was to take all their heights, add them up, divide by how many, I get an average height. Does that make sense to take the heights and able to do an average on them? Yes. So this guy would be quantitative. Quantitative. Political affiliation. Okay, if I take all my Republican friends and all my Democrat friends and all my independent friends and all my green friends and all my Democratic, socialist, communist friends, add them up and divide them by whatever, would that give me a number that makes sense? No, that's categorical. Temperatures. I take a bunch of temperatures of students, and can I add them up, divide them by how many students, and get an average temperature? Does that make sense? Yeah, that's qualitative. And BMIs. Can I take a bunch of people's BMIs and do something with those numbers? Get an average, deviation, a median? Yes. So again, quantitative. Can I do something with those numbers arithmetically? Yes, no, yes, and yes. If all else fails, just go through and you can also verify that. Next. Which the following is not an example of a categorical variable? Or a categorical variable like it is qualitative. I'm not sure if I did that right. And again, I can identify, give them numbers, but if I add them up, it won't make sense. So hair color. Can I find the average hair color of people? Well, no. I mean, it's red, blonde, brunette, black, auburn, raven, whatever. Gender, male. I'm going to stick the biological ones. Male, female. Okay. Can I add males and females together and get an average gender? No. Field of studies, because it's qualitative. It's a category. Are you redhead? Are you blonde? Category. Are you male? Are you female? Field of studies. Are you an English lit major? Are you an engineer? Are you a pre-med? Grade point average. Are you? Oh, wait a minute. Grade point average. That's a number. That's a measurable. So if I can measure it, I can average it. You say here, the root word categorical is category, meaning ways to group things. All those same things. So grade point average. I knew y'all knew that already though. Okay, researchers are designing an experiment to learn whether eating dark chocolate can help people have healthy hearts. Oh, I hope that's true. They plan to give various doses of dark chocolate to patients for a long-term study. I volunteer for the highest dose. After a specified amount of time, they will compare heart health among the patients. What is the explanatory variable? Okay. What is being varied or manipulated? Okay. The output, the response is heart health. But what's being manipulated is doses of dark chocolate. So the dark chocolate is what's being manipulated. And that's going to be the explanatory variable. Okay. Okay. Patients are the subjects. Heart health, now that's the response, because that's what we're going to measure. Okay. Based on how much dark chocolate you're being given, I will measure how your healthy heart or not is doing. Dark chocolate, heart health. And I'm assuming what they're hoping to see is as your chocolate dosage goes up, your health goes up. Hopefully. If not, what a way to go. So what is the response variable? Again, the patients, those are the subjects. We've already said this is the explanatory. And this is what we're going to measure with manipulating the explanatory. That's what we're trying to prove or disprove. So let's see, select the correct answer. What is the manipulated treatment in this study? And let's see, well, the patients are being manipulated by the doses being given and by what doses they receive. But again, they're the subject of the treatment. Okay, various doses of chocolate. Well, that's the explanatory. Therefore, this is what's being manipulated. And of course, again, this is our response. This is what we're looking for. We're looking to see, does chocolate affect hearts? H-E-A-R-T, heart health. So, what is the treatment? Explanatory. Okay, let's see. So, what do we got here? How confident are you that you can distinguish between quantitative and categorical? Oh, I'm very confident with that one. How confident are you can distinguish between explanatory and response? Yep. And how confident are you that you can identify treatment levels? Getting very high. For me, at least. And yep. These are all those things. We identify treatments, we distinguish between explanatory response, and we distinguish between the quantitative and the categorical. Not necessarily in that order. So we're done with the video game diet tutorial. I'm not sure how chocolate relates to video games. Maybe they have you eating the chocolate while you're watching video games or playing video games. I don't know. I'd like to find out. Maybe I will. But as usual, go back and look at this over yourself. And I'll see you shortly for question 1 and question 2 of Quantitative Reasoning Online, lesson 15A, the video game diet.